4-point charges minus q, small minus q, to q to capital Q are placed one at each corner of the square. The relation between capital Q and small q for which potential at the center. Say ABCD. Potential at the center due to the charge present at A is K times minus Q. So it is a square. All sides are same. The diagonal is equal to root 2a. It will be half of it. So it is a by root 2 minus kq into root 2 by a. Potential at charge, let us say O, due to the charge present at B will be k times minus q by a by root 2 minus k root 2 q by a. Potential at O due to the charge present at C will be k into 2q by a by root k 2q into root 2 by a. Potential at O due to the charge present at D will be k into q by a by root. That is k root 2 q by a. So now potential at O will be minus k root 2 q by a minus k root 2 q by a plus k times 2q root 2 by a plus k times root 2 q by a. He said 0. So here you can take k root 2 by a common. Then you have minus q plus 2q plus q is equal to 0. At D, it is 2q, right? So 2q minus q, which is q plus q0. So the relation is q is equal to minus, okay, first option. Here, in the second problem, a long parallel wire which two long parallel wires which are carrying a current I which is flowing in the same direction at a distance 2d apart. The magnetic field B at any point lying on the perpendicular joining the wires and at a distance x from the midpoint. Midpoint is x, m here at a distance x. Once it is 2d, so this becomes d. This distance becomes d plus x. It is d. Say at point P, this will be d minus x. Magnetic field at a point P, which is at a distance r from current carrying wire is B equal to mu naught I by 2 pi r. So at P, magnetic field at M, sorry, magnetic field at P due to first wire, let us say it is first wire, second, mu naught I by 2 pi into D plus X. And the direction is put thumb in the direction of current. So at which point you want to find magnetic field. So at that point you curl the fingers. That fingers shows the direction of magnetic field, that is inverse. Magnetic field at P due to the current carrying wire, second another wire, two, second wire, which is mu naught I by D minus X. Put thumb in the direction of flow of current. Curl the fingers at that point. It shows upward direction. Net magnetic field at point P is mu naught I by 2 pi into 1 by D plus X plus 1 by D minus X. After simplification, you get D by pi into D square minus X square. D minus X, D plus X, mu naught I D by D square. It is not, it is D. So second option. Here in this circuit, what L represents? L is right inductance. So C represents capacitance. R represents resistance. He said EMF is right E. X is initially joined to Y. So once it is initially joined to Y, then it becomes a large circuit. So then charge stored in inductor. In steady state, so flow of current through the circuit I equal to E by R. So after that, X is joined to Z, then it becomes R is get disconnected, then you will have only LC circuit. So once it is LC circuit, oscillation occurs. Right. So in this oscillation, L is charged initially and energy is stored in inductor. So slowly energy is transferred once after attaining the maximum energy. So that energy is transferred to capacitor and C is completely charged. So in this way, this process will be continued. Finally, so charge stored will be maximum. Charge stored will be maximum if energy stored in inductor is equal to energy stored in capacitor. In place of I, if you write E by R, half L E square by R square is Q square by 2C. From here, you can say Qs to get cancelled. Qs E root E by R root C of here L also there. Q is equal to E by R root of LC. A point object O is placed in front of a glass rod having a spherical end of radius of curvature. The image will be formed at. Here it is a glass rod. So here refraction at a curved surface. So we have a formula mu2 minus mu1 by R is equal to mu2 by V minus mu1 by U. Here mu1 is so refractive index of air from which medium ray is entering, that mu1 is 1. Mu2 is refractive index of glass in which medium ray is entering. So that is 1.5. Here it is 1.5 minus 1 by the radius of curvature. Here ray is right moving from air to glass. So from this point we measure radius of curvature, which he given it as 30 centimeters. So mu2 will be 1.5. V is image distance. Mu1 is air. So here we are measuring object distance against to the direction of uh, ray in which direction it travels, that is minus 50. 1.5 by V plus 1 by 15, which is 1 by 60. 3 by 2V will be 1 by 60 minus 1 by 15 minus 3 by 60. So 1 by 2V here is minus 1 by 60. So V will be minus 30 indicates image form 30 centimeters from left. In Young's double slit experiment, so here wavelength of a wave is this: minimum distance from the central maximum for which intensity is half the maximum intensity. So we know that maximum intensity will be at center. Let us say that intensity as I know. So in Young's double slit experiment, here slits are separated by a distance d, two waves of same intensity, that is I naught, separated by a phase difference phi, then resultant intensity IR, then the formula related is this: 2 I naught cos phi. I resultant will be 2 I naught into 1 plus cos phi, 2 cos square phi by. I resultant will be 2 I naught cos, 4 I naught cos square phi by 2. Here phi is phase difference. So that phase difference is equal to 2 pi by lambda into path difference. So here, so let us calculate IR. He said minimum distance from the central maximum intensity is half of the maximum. So IR I will take. So 4 I naught by 2. This is the maximum intensity, which is equal to 4 I naught cos square phi by 2. Cos square phi by 2 is cos phi by 2 is 1 by root 2. Pi by 2 is pi by 4. Phase difference is pi by 2. So once phase difference is pi by 2, so here it is 2 pi by, uh, which implies pi by 2 here is 2 pi by lambda into delta x. So path difference will be lambda by 4. Path difference is theta is very small. Tan theta, here it is slit. This here is a screen. Here theta is this, tan theta will be dy by d. So delta x will be lambda by 4, which is dy by capital D. Y here is lambda capital D by D. So here lambda is 500 nanometers. Capital D is 1 meter. Small d is 1 mm. Here y will be 4d, 4 times. 125 into 10 power minus 6 meters. So option 1.25 into